All right, so as we did yesterday, we learned a skill, and then we learned how to solve a system. So that is what we're going to do today. Today, though, instead of using Cramer's rule, we're going to use something called a matrix equation. So we're not only going to make one matrix, but not two, but three matrices. Three matrices. It's going to be exciting. All right? So go ahead and just focus right now. Take 10 seconds. Look at this system, and then look at the equation they made. All right? Take a look at this system, and then the equation that they made. Give you 10 seconds. Just look at it. Okay. There must be some toros in the atmosphere. If you look at the one in blue, you should notice we did that one yesterday. Yesterday we did a matrix based on the coefficients. So the numbers in front of x and y, we did that yesterday. That's no different. But there are two new ones today. The variable matrix are the two letters I'm solving for. All right, it will always be x and y, but just to make sure you know what you're doing, what if I wrote a plus b equals 8 and 2a plus b equals 1? What would be here? All right, you get the idea, okay? And then whatever numbers are after the equal sign, that goes here. So that's the first checkpoint. Can you write the equation? All right, now let's show you how you're going to solve the equation. Again, this is the equation. Coefficients, variables, constants. Coefficients, variables, constants. Okay? You should see something up here that we just talked about. What did we just discuss in the last micro lecture? The -1 guy right here, the one in red. That is an inverse matrix. So what are you going to have to solve in this process? An inverse matrix. Now, take a look at this math here. All right, you wanted some algebra, here's some algebra. What happens when I multiply 2 times 1/2? You get 1, because these are called inverses. So what happens when I multiply these, which are inverses? They're gone. Becomes 1. Okay? Take a look over here. Whatever I do to one side, I must do to the other. So I will be multiplying by inverse matrix times the constants. All right? All right. You guys ready to try an example? Excellent. If you need room, because we are going to do a lot of work here. If you flip on the back side, there's some blank space where you can do this example. Example 3. Oh, thank you. I'm sorry, what song? Yeah, but it didn't say to write your name, so you're good. Here we go. First checkpoint. I need the equation. All right, so what's going to be my first matrix? The numbers in front of x and y. So 1 and 1, I'm going to go to the first row first. Then 2 and 1. Again, we did that yesterday. Okay, what goes in the second matrix? X and y, your variables. This is called the variable matrix. All right? Yes? Always x and y, yes. And the last one? 8 and 1. That's called the constant matrix. So whatever numbers are after the equal sign will go there. That's the first checkpoint. All right? That's what I'm looking for first. I want to see that when I give you guys a quiz next week on this stuff, I'm going to be looking for that as a first thing when you do this problem. Okay? Questions? Okay. The next thing we need to do in order to solve this equation is we need to find the inverse of this matrix. So this is matrix A. So to find the inverse, I'm going to write A to the negative first power. All right? What did we do first when we found the inverse? We found the determinant. All right? So what's the determinant of matrix A? Well, let's do some multiplication here. 1 times 1 minus 2 times 1. Very good. So I'm going to write, so that's equal to negative 1. I'm going to write 1 over negative 1. And then what am I going to do for this matrix here? What happens to 1 and 1? They switch places. So I know it looks like they didn't switch, but they did, if you look really hard. And what about 2 and 1? Not reciprocated, they just become the opposite. Nope, reciprocal means to flip it. Opposite just means to change the sign. So negative 2 and negative 1. Guys, you should notice we're doing nothing new right now. This is something you've already done. Okay, so just tell yourself, I know this, I know this stuff, I know this, I know this. What's up? Okay. Okay, so in order to find the inverse, I'm going to take these 4 numbers and do what with them? Divide them by what number? Negative 1. Again, what if I would have gotten 7? They would be divided by 7. Okay, so whatever you get for that determinant. So my inverse matrix is going to be negative 1, positive 1, positive 2, and negative 1. Because all of these numbers divided by negative 1 changes their sign to be the opposite. That's the second checkpoint. Which means we're still going. Well, only because it was a negative 1. Guys, what if I would have found this to be a positive 1? What would I have done with these numbers? They'd be the same numbers, right? They wouldn't change. So don't get bogged down on like the numbers. Just you need to know the process, because the process is what I care about, not the numbers. All right. So now here's where I need you to use your imagination. We have just found the inverse, this one in red. So we are going to take that inverse and multiply it by both sides. By both sides. But when I take this and move it in front, what happens to this guy and this guy? What happens when I move it? I'm gonna do this. Oh. What happens when I move it in front and I multiply by that one? They make 1. They're gone. Okay? If I multiply this times this, all that I have left are the variables. Okay? Is everyone all right? Sorry. That should be. Say it again? Yes, but I don't need you to do that. I'm telling you right now what happens. When you multiply this by that, it's gone. No, you get 1, but it's just gone. We don't need to write 1. Okay? So, here's the next step. You take your variable matrix and bring it down. Because now that is by itself. But on the right side, I am going to write my constant matrix of 8 and 1, but what gets multiplied by it? This inverse matrix. So I'm going to bring that down. What happened? Correct. No, so I'm saying when you move this to the front of the left side, multiplying those makes it's all gone. So I notice I just have my variables. But now I need to take this and also move it to the front of this one, right? So that's why I wrote it there. Because whatever I multiply to one side, I got to do to the other. You're okay? You're all right? Okay, let me try again. Maybe I'll do this. Yeah. Here we go. Because I think we're all here. Yep, I got you. We're okay. I promise. I know where I lost. I think everyone's good here. Everyone good with this? This is the beginning. This is the first equation, the very top. Okay. Then what I want to do, and I'm not showing it because I'm trying to get you to do it mentally, is I'm putting the inverse matrix, so this one right there, I'm putting it in front of both sides. Okay, I'm putting it in front of both sides. Okay, so you should still see the original equation there, but I put it in front of both sides. And this is what I was trying to tell you. When I multiply this one, the inverse, times a, what happens to these? They're gone. So that's why I only bring that down, which is why I have that down there. But I still need to multiply this because this doesn't go away. This gives me my answers. Okay? But now we need to multiply to get the answers. So this is why in the rewind, I wanted you guys to practice multiplying. I'll use blue for the answer. How about that? No, black. Yeah?
So although it's gone when you cancel out, you still need to find the answers.
You still need it on the other side. Yes. All right. So what are the dimensions of this matrix here? 2 by 2. What about for this one here? A 2 by 1, right? 2 rows, 1 column. So is it possible? It is. Inside numbers are the same. The outside number of 2 and 1 will give me my dimensions for the answer. So my answer matrix is going to be a 2 by 1. So that's going to be my answer. All right? Now, if you need to show some work, you can, right? If you need to show some work, you can. I'll put the work down here. I want to do that. Okay. So let's see if you can do it. Remember, this is my work matrix.
Oh, so you haven't got your answer yet?
No, I'm not done. I'm multiplying. The x and y is by itself because the inverse matrix times the original matrix make it go away. Everything goes away. All right. On that side. All right, so what is -1 times 8? That goes down here. Plus. I'd completely lose everybody? Okay, we'll come back. I'm doing this row times this column. So -1 times 8 plus 1 times 1. What is that? What's -8 plus 1? Great. That's my x answer. Okay, let's do the second row times that column. 2 times 8 plus -1 times 1. We're multiplying. So this is what we did last week, multiplying. What's 16 plus -1? 15. So your answer is -7, 15.